Thermodynamics in exothermic and endothermic reactions. Thermodynamics deals with the relationships between heat and other forms of energy. During a chemical reaction, the thermodynamics of the system change as bonds between atoms are broken and new bonds are formed. What are exothermic and endothermic reactions? A chemical reaction that releases heat to the surroundings is called an exothermic reaction. A chemical reaction that absorbs heat from the surroundings is called an endothermic reaction. The first experiment is an endothermic reaction. The materials required are as follows: a thermometer, test tube, ammonium nitrate, and water. Ammonium nitrate is a white, crystalline salt. This reaction entails introducing ammonium nitrate to water. It undergoes an endothermic reaction. On recording the temperature changes, it was noticed that the initial temperature was 12 degrees, after a minute it was 8 degrees Celsius, after another minute 11 degrees Celsius, 2 minutes later 13 degrees Celsius, 2 minutes later 15 degrees Celsius, and 2 minutes later 17 degrees Celsius. As we can see, there is an initial decrease in the temperature and then a gradual increase in temperature. Now, why does this happen? Firstly, endothermic reactions absorb heat from their surroundings. This occurs during the initial stages of the reaction when the bonds in the reactants are breaking. Breaking bonds requires an initial input of energy, and this energy is drawn from the surroundings. Secondly, as energy is absorbed from the surroundings to break the bonds, the immediate effect is a decrease in temperature. The surroundings lose heat to the system. Thirdly and lastly, as the reaction progresses and new bonds are formed in the products, energy is released back into the surroundings. The result is a rise in temperature, and the surroundings eventually regain the energy, exceeding the initial temperature. The second and last experiment is an exothermic reaction. The materials required are as follows: a thermometer, a test tube, sulfuric acid, and water. Sulfuric acid, when introduced to water, undergoes an exothermic reaction. On recording the temperature changes, it was noticed that the initial temperature was 45 degrees Celsius. After a minute, it changed to 54.5 degrees Celsius. After another minute, 53.5 degrees Celsius. And then another 2 minutes, 51 degrees, another 2 minutes, 48 degrees, another 2 minutes, 45 degrees. As we can see, there is an initial increase in the temperature and then a gradual decrease in the temperature. Now, why does this happen? Firstly, exothermic reactions release heat into their surroundings. This occurs during the initial stages of the reaction when new bonds are forming in the products. Forming bonds releases energy. Secondly, the immediate effect is a temperature increase in the surroundings. The system is giving off heat to its surroundings. Thirdly and lastly, as the reaction progresses and reactants are consumed, the rate of heat release may slow down, leading to a temperature decrease. However, this decrease is not always to the same level as the initial temperature. In summary, the observed temperature changes in endothermic and exothermic reactions are linked to the breaking and forming of chemical bonds, as dictated by the principles of thermodynamics.